Okay, this is just going to be a quick video on working with and understanding what correlation is. So there's some conditions you have to check before you're able to find the correlation coefficient or talk about correlation. The first one is your two data sets quantitative variables. If they're quantitative variables and they have units, then that condition's met. The second one is your scatter plot straight enough? Does it look relatively linear? And the third one, is there outliers or anything that might throw it off and make it not linear? So if there's extreme outliers, there's a good chance that you're not going to be able to use correlation. So here's a couple different plots. We've looked at some of these in class. There's two that we would not be able to use correlation to talk about, and these are C and F because those are not linear and they're random patterns. Then there's two positive ones. Your two positive lines would be graph A and B because they somewhat go up. A is a really good going up positive one, and B is a slight line, but it is going up. And then your two negative ones would be D and E because the scatter kind of is going down for D and also going down for E. Here's some examples of what the scatter plots look like and what their correlation value is. The highest value is graph A with 0.93. And then it slightly goes down, but you can kind of see where the spread of things are based on what the correlation value is. I found this chart and I thought it was helpful to kind of help you being able to describe what a correlation is. So anything above 0.8 I would consider being strong, and then anything below between 0.5 and 0.8 would be moderate. Okay, and you can read this, and it might be helpful to write this down if you're struggling to remember what to say when. Okay, so here is a scatter plot we have that it's plotting horsepower versus the weight in tons. So before you can do anything, you have to check the conditions. The first condition is the quantitative variable condition. Both horsepower and weight are quantitative variables, so this condition is met. And you have to actually write that. You can't just put a check mark saying that, yes, we met that condition. The second condition is straight enough, and the scatter plot looks straight enough. And you can say that just as a brief statement, but you do have to make a statement about the condition. And then the last one, the outlier condition, there does not appear to be any points far enough from the other points to be considered an outlier. So when you're checking these conditions, you have to actually write brief statements about each one to show that you've checked them. Then at the end, you're going to have to write a statement saying that the variables have met the conditions, so correlation is suitable measure of association. If they don't meet it, then you'll say something about that you're not able to use correlation as a measure of association. Here's another example. Again, we have to first of all look at our conditions, and I'm just going to jump to the straight enough condition because this is not a line, this is a curve, and so your statement would be the scatter plot does not look straight, it is clearly a curve, so the outlier condition doesn't matter. And our overall statement would be the straight enough condition is not met, so it is not appropriate to use correlation as a measure of association. Okay, so here's another one. This one is talking about gas mileage versus the weight of a car. So let's first of all check our conditions. The first one's the quantitative variable condition. Weight and mileage are both quantitative variables, so that condition is met. The second condition is it straight enough? And the scatter plot does look straight enough. And then the outlier condition, again, there does not appear to be any points far enough from the other points to be considered an outlier. So since these conditions are met, you need to write a statement saying that they're met and that you can proceed. And so again, there are two quantitative variables that satisfy the condition, so correlation is suitable measure from association. From there, you can go on to describe your scatter plot. So here are some important things to know about correlation. The sign tells you the direction. If it's positive, it's going up from the left to the right. If it's negative, it's going down. It also tells you that it's between -1 and 1. You will not go over 1 or -1, and it's the closer to 1, the stronger it is. And remember that picture I showed you that had what the different values can be called. Correlation treats X and Y symmetrically, and so you could switch the X and Y axis and your correlation is still going to be the same. The graph may look different, but the scatter of the point will still be the same, so the correlation coefficient will still be the same. There's no units on correlation. Correlation is not measuring the units, it's measuring how accurate or how close things are to a line. Correlation is not affected by change in the center or the shape. So if you're changing numbers or adding constants, it's not going to change it. And remember, correlation only measures for linear. It needs to be straight enough. Correlation is sensitive to outliers. We'll do some activities later so you can see what happens when we add outliers and take them out. And correlation describes the strength and direction of a line. It is not causation. You cannot say that there's a correlation between two things. You're just going to say that there's a positive, strong correlation. So remember the process for correlation. The first thing you need to do is check the three conditions, and when you check the conditions, you need to clearly state that you have checked these conditions in a sentence or two. The next thing you need to do is you need to write a sentence saying that you can or cannot use the correlation based on those conditions being met. And again, all three have to be met in order for you to proceed with correlation. And finally, you want to include the correlation in the description of the scatter plot when the conditions are met. So when you're able to say that the scatter plot has a strong positive correlation, you would want to say it has a strong positive correlation of 0.92. Okay? So remember to check the conditions, and write a sentence about each of them that you're checking them, and then you can proceed from there.